Welcome everybody to the NCS Kwara State Chapter webinar lecture series organized by our able leader, Engineer Abdulkareem, Taofik Abdulkareem. So we want to sincerely appreciate your leadership for coming up with this type of lecture series. And I believe every participant and members were enjoying every bit of our discussion today. And you could all agree with me that many of our researchers research these days usually end up in a shelf, or at most it end up in paper presentations. But because there's introduction, we're using AI every day in all our activities. With the introduction of AI, our guest lecturer is going to give us an insight on how we can transform our research from ending up in a bookshelf to a startup, to research ideas into startup product and industrial solutions. So on this note, I'm Dr. Jumoke F. Ajao. I'll be moderating this webinar session, and I would like to welcome the NCS chairman in person of Engineer Taofik Abdulkareem. I also like to welcome the national president, the Nigerian Computer Society of Nigeria, in person of Professor Sirajo, Aliyu. You're welcome, sir. I also like to welcome all our professional members from different sectors, institutions, educational institutions, organizations and parastatals. We also like to welcome you to this webinar lecture series. So on these notes, I want to sincerely appreciate everybody for your time. And I believe we're going to share an insightful moment with our guest lecturer in telling us or giving us an idea on how we can transform our research into startup products and industrial solutions, which will be beneficial to the entire world and to Nigeria as a whole. So on this note, I'd like to welcome my chairman in person of Engineer Taofik Abdulkareem to please give us a welcome address. Thank you, sir. You're welcome.
Thank you, Dr. Mrs. Ajao,
Yes,
our treasurer, who is also doubling as our moderator this afternoon. So you're all welcome. The president of the NCS, he hasn't joined us yet, but we hope he's going to join us before the program ends. The Zonal Coordinator of NCS, Dr. Oyerinde, who we also hope is going to join us before the program ends. And I also want to warmly welcome Dr. Habeeb Salaudeen, who has graciously agreed to be today's guest lecturer. And also, of course, all our members at the Kwara State Chapter, members national from different chapters that are present, and all the other guests who may not be members of NCS yet. I said yet because we are still inviting to become our members. So today's topic is apt beyond publication, turning AI research into startups, products, and industry solutions. And I believe that we've gotten the right person to actually do justice to this topic, having gotten a PhD in AI and also being the CTO, the Chief Technology Officer of an AI company. At NCS, what we stand for is promoting IT, IT education and also practice in Nigeria. So that's part of why we've organized this webinar. So I will want to preempt the guest lecturer. I believe we should give rapt attention to what he's going to say, and we hope we also get contributions from those present here too, as to enrich the discussion. Once again, you are all welcome. Thank you.
Thank you so much, sir, for that good welcome address from our chairman, Engineer Taofik Abdulkareem. Thank you so much, sir. So I once again welcome all members to this lecture series titled Beyond Publications, Turning AI Research into Startups, product and industry solutions. So having taken the welcome address from the chairman, NCS Kwara State Chapter, I wouldn't know whether the national president has joined. Sorry. Professor Siraj, please, are you online? Professor Siraj. Yes. We would have loved to take the opening remark from the national president of Nigerian Computer Society, but quite unfortunate he has not joined. I think we'll move to the next agenda we have on the program. I think by the time he joined us, he can take his opening remark. Thank you so much, sir. So on this note, I also want to welcome the North Central Zonal Coordinator, a member of National Executive Council of NCS, and person of Dr. Yinka Oyerinde. I wouldn't know whether he has joined. Dr. Oyerinde, has he joined? Sorry. While we're still expecting the two of them to join, maybe they will join later, so they'll be able to take their opening remarks. I'd like to sincerely appreciate our guest lecturer for honoring our invitation and for also sharing an insight on an important topic of beyond publications, turning AI research into startups, product, and industry solutions. Well, before we take our guest lecturer, I'd like to read his citation. Sorry, please. Both the national president and the North Central Zonal Coordinator, the moment they joined, they were able to give them the avenue to present their opening remark. Thank you so much, sir. So I'd like to read the citation of our guest lecturer, Dr. Habeeb Salaudeen, PhD, Chief Technology Office, Alveum. Dr. Habeeb Salaudeen is an AI engineer and technology leader driving the development of AI-powered products used at scale across multiple continents. As Chief Technology Officer and Lead Innovator at Alveum, he leads the multidisciplinary engineering team building faith-based AI products with an active presence in North and Latin America. Dr. Salaudeen holds a PhD in computer engineering with a specialization in artificial intelligence and machine learning. His academic grounding has been instrumental in establishing a research-first engineering culture at Alveum, one where rigorous inquiry directly shapes what gets built and shipped to production. His current research focus is safe and ethical AI, a priority shaped by the unique ethical demands of developing software that intersects technology and faith. Under his technical leadership, Alveum's flagship product, Uhana, has surpassed 500,000 downloads across multiple countries, with AI agents handling over 2,000 user interactions daily. He is committed to ensuring that every product leaving his team is not only performant, but ethical, sound, and safe for real-world use. Dr. Salaudeen has spoken at the 3MMTT hackathon, served as panelist at GDG 2025, and delivered a lecture at MAHUB on his journey in AI. He is based in Ilorin, Kwara State, Nigeria, and is an avid tennis player. So the distinguished participants, ladies and gentlemen, I introduce to you our guest lecturer today that will deliver a lecture titled Beyond Publications, Turning AI Research into Startups, Product and Industry Solutions. I invite Dr. Salaudeen to please take over. Thank you so much. We appreciate it. So, Dr. Habeeb Salaudeen, please, you have the floor, sir.
Hello.
Yes, thank you very much, ma'am.
Hello.
Hi, sir.
Hello.
Hello.
Hello. Sorry, Dr. Habeeb. The moderator.
Yes, sir.
Sorry, can I speak before he go ahead?
Okay, Prof, are you okay? Sorry, Dr. Suraj. Sorry, Dr. Habeeb.
No problem at all.
So I'd like to welcome our national president in person of Professor Sirajo Aliyu. Thank you so much. Please, you have the floor to give your opening remark. We appreciate your time and your commitment towards the development and growth of NCS in Kwara State Chapter. Thank you so much, sir.
Thank you very much. Very sorry, Doctor. You about to start. I just came in. I've been struggling to connect, but you know how the network is sometimes. Once again, let me use this opportunity to welcome each and every one of us to this webinar. Especially, I would like to welcome and appreciate all the National Executive Council members that are here, the President and the formers that are here. And I would like to use this opportunity to appreciate and thank the State Chapter Executive for organizing this program, which is a very, very good initiative and a very good thing for the State Chapter. And to the members of the chapter too, I would like to use this opportunity to thank and appreciate each and every one of you for finding time to join the program. As I always say, we all have a collective responsibility to make sure that we move our profession forward. No any other person that can do that for us apart from us. And I'm very happy to see Kwara State Chapter is not been left behind. So I would like to make a special appeal to each and every one of us to try as much as you can to support your state chapter and to support the national to the best of your ability, as we all of us have a collective responsibility. Whatever you can do in any capacity that you can support, you can help, please feel free to do that. The reason why you have to do that is because the society belongs to each and every one of us. So something that belongs to you, it means you have to make an effort to make it strive, to make it to be much more better and better at you want to do. And I would like to appreciate all of you for joining this program, and I want to thank you for the opportunity given to me to speak. And I wish us a very fruitful deliberation. And please, I would like to appeal to all of us that we should take advantage of the presentation that is going to be given. Let's all of us listen attentively, try to interact, ask meaningful questions. Let us learn from it, because this is a very great opportunity for us to learn from one another. Once again, thank you very much, and I wish us all. Thank you.
All right, I want to appreciate the national president once again, the national president of Nigerian Computer Society of Nigeria. Thank you so much for that wonderful opening remark. We sincerely appreciate you, sir, for your time. And I wouldn't know whether the Zonal Coordinator has joined, so I will take his opening remarks. The North Central Zonal Coordinator, person of Dr. Yinka Oyerinde. Is he online? Okay.
Yes, I am online. Thank you.
Okay, thank you so much, sir. So we'd like to have your opening remark before we commence. Thank you, sir.
Okay. Thank you very much. Thank you, Moderator, Dr. Alao. Thank you for the opportunity. My President, good evening, sir. And may I seize the opportunity on behalf of the good people of North Central Zone of the Nigerian Computer Society to wish you a very blessed and happy birthday, sir. We are waiting for our goodies from your birthday. Dr. Salaudeen, please, I crave your indulgence. Apologies, you're about to start. I actually have been looking forward to this webinar. The topic is of great excitement, and I would like to see you do justice to it, so I wouldn't be long. I just want to thank my chapter chairman and my brother engineer Taofik Abdulkareem for the good job that he's doing in Kwara. And I thank you all members of Kwara State Chapter for the support that you are obviously giving to him. I always look forward to the webinars from Kwara because they are webinars that touch on these real current situations and emerging trends and how they can practically affect everything that we do as IT professionals and computing members of the computing profession. So, like my president has said, there is a lot for us to gain from this and from supporting ourselves, and we look forward to the presentation. And on the side note, may I also encourage you, or remember the zone is hosting the NCS conference at the end of July. I believe that we are all mobilizing and preparing to storm JOS and show the Nigerian Computer Society our special hospitality in the North Central Zone. Once again, thank you for the honor, and I intend to remain online and really get the gist of the matter. Thank you very much, Dr. Alao.
Okay. Thank you so much, sir, Dr. Yinka, the North Central Zonal Coordinator, for that warm opening remark. Thank you so much, sir. So on this note, I would like to invite Dr. Habeeb Salaudeen to present his topic, Beyond to Do Justice, to Beyond Publications, Turning AI Research into Startups, Products, and Industry Solutions. This is going to be an insightful discussion, for which I want each and every member to participate fully. Thank you so much. So, Dr. Habeeb, you have the floor, sir.
Okay, thank you very much, ma'am. And thank you, everyone, for giving me the opportunity to be able to address you today. I just want to confirm if my screen is being shared and can you hear me loud and clear.
Yes, it's shared. We can hear you loud and clear. Thank you,
Awesome.
sir.
Thank you. Good evening, everyone. My name is Dr. Habeeb Salaudeen, and I currently serve as the Chief Technology Officer at Alveum Limited, which is based in Kwara State, although we reach far beyond the Nigerian shore. The theme of this session is Beyond Publication, Turning AI Research into Startups, Products, and Industry Solutions. So I believe the title is selected intentionally because as academicians, publication is a very integral part of an academician. In fact, everything is tied to what you publish, the effect of your publications, and how well you conduct research and you're able to publish it. So moving on from that, publication creates knowledge, tests, validates methods, and it also contributes to scholarly discourse. But in the field of artificial intelligence, we can't restrict publication only to, we can't restrict that field to the end result of whatever we're doing in AI to just publishing a research paper or a literature survey or whatever. AI research now sits very close to industry transformation. So we're talking about models, frameworks, data sets, evaluation methods, or even technical insights. And these things can now become the foundation for a product, a startup, a new enterprise solution, or even an entirely new operational capabilities. So the transition doesn't just happen automatically, as we are all aware. It requires translation. So I will use Alveum as an example. At Alveum, we don't just do theoretical discussions, right? Research and development is part of how we work. The company operates with a research-backed development culture. Our leadership has strong roots, and our engineers are encouraged to investigate problems deeply before they start developing the solutions. And frequently, we organize research-backed hackathons where engineering teams examine real industry problems. They study relevant technical work, and they develop prototype solutions that can help us move from concepts to implementation. So this session is not about asking researchers to abandon their academic endeavors. That's not what we are here for. What we're here for is to ask a different type of question. What happens after the research becomes credible? Whatever you're doing, what happens at the end of it when you have a very solid research? How do we move from insights to adoption? How do we move from prototype to product, and from publication to impact? So I've given a central thesis guide that we follow throughout this presentation, which is AI research becomes powerful when it leaves the paper, meets a real problem, and is shaped into a usable product, company, and industry solution. So for the first section of this presentation, we're going to talk about why this conversation is even important. Why are we having this conversation? So one of the uncomfortable truths So one of the uncomfortable truths in artificial intelligence is that the field is producing research at a pace that far exceeds the rates we are converting those research into meaningful products. I don't mean the research is weak. In many cases, they are very strong. Extraordinary volume of technical, sophisticated work are being produced across machine learning, natural language processing, computer vision, robotics, responsible AI, optimization, human-computer interactions. However, the presence of good research does not automatically point to a social or economic impact. A paper can be rigorous, it can be well cited, and very intellectually important, yet still fails to become part of any real system used by real people. So this is what I refer to as the graveyard of brilliant research, where ideas that were strong enough to be published, strong enough to be cited, strong enough to be discussed in academic spaces, but they are unable to translate them into tools, workflows, companies, policies, or any tangible infrastructure. According to Stanford AI Index, AI publication has tripled between 10-year gap using 2013 and 2023 as the gap, from around more than 100,000 publications to now over 242,000 publications. At the same time, the industry reports continues to show that many organizations still struggle to turn AI activity into measurable value. BCG, for example, reported in 2024 that 74% of companies have not yet shown tangible value from their AI efforts. So the point here again is not to compare academic publishing to corporate AI adoption as though they are the same thing. They are clearly not the same thing. The point is to observe a pattern that knowledge producing is accelerating. We are producing knowledge at a ridiculous speed, but translating capacity is not keeping up to the pace of the way we are producing knowledge. So this is the gap we don't talk about enough. So we often celebrate publications, celebrate new models, benchmarks, prototypes. But the other question remains that what happens after that? Who turns the insights into a usable product? Who validates the problem beyond the lab? Who maintains the system after deployment? Who handles regulation, usability, business models, procurement, security, data quality, and user trust? So this is why publication should not be treated as the end of the journey, For researchers who want their work to shape industries and public system and even have their own entrepreneurial endeavors, publication is often the first form of validation. So the next challenge for us will be translation. Please, can we have everybody muted, please? I'm getting some interference.
Please let us mute. Let us mute our speaker if we're not talking, please. Thank you, sir.
Thank you very much, man. Yes, ma'am. So yeah, we continue with why we still need to discuss this matter. So we have identified the gap. What we need to do now is reframe the opportunity. So for many researchers, the default mental model is that research produces knowledge. That is what we are used to. That's how the system is created, and that's how we have been part of the system, which is correct, but it is incomplete at this stage. Research does produce knowledge, but in field like such as artificial intelligence, it is also capable of producing more than that and making real impact. Published paper may contain more than an argument. It may contain a new way of detecting fraud, diagnosing disease, optimizing logistics, personalized learning, even improving software engineering as a whole, and can be applied to several other fields, any fields you can think of. Artificial intelligence, one way or the other, can be applied to it. So a trained model may not simply just be a technical artifact. They also represent capability that an organization is willing to adopt. A data set may not simply support an experiment. It may become a strategic asset too. And even a methodology may not simply improve evaluation. It may become a repeatable service, a workflow, compliance tool, or even a product feature. So this is the opportunity reframe I'm talking about. Research is not only a contribution to knowledge, it may also be a blueprint for products. Although it does not mean that every research project should become a startup. It also does not mean that the commercialization is the only valid form of impact. Some research, they are most valuable in theory, in infrastructure, or as policy guidance, even as open source contributions, or just for public knowledge. However, for researchers that are rooted in AI, it is increasingly becoming important to ask an additional question after the academic question has been answered. When the academic question is, what does the research prove? Then the translation question will be, what problem will this research help solve? For whom and under what conditions? So this is where the shift begins. We move from seeing research only as an output to seeing it as a starting point for impact. And this framing is consistent with a broader idea of knowledge and technology transfer, which can be described as a collaborative process, whereby scientific findings, knowledge, and intellectual property flow from universities and research institutions to public and private users, eventually becoming products and services that benefit society. So the message I'm still trying to pass across is not that all researchers to become entrepreneurs overnight and start chasing the startup dream. The message is simple. Simply, you just learn to recognize the latent product logic that might already be inside the work you are doing, inside the research you are focusing on. There might be some logic that hidden within it, and just because you haven't think about it or identified it, that's why you have not recognized it. The message remains, let's try and recognize those product logic that might be inside the work we are already working on. So behind many AI papers, there may be a product question waiting to be asked. Even behind prototypes, there may be an industry workflow that's waiting to be improved. And even behind research methods and methodologies, there may be a startup, platform, public interest solution waiting to be shaped. So this is the opportunity we are trying to reframe today. So at this point, the second section is the translation problem, right? So at this point, we need to examine why promising research often struggles to become a usable product or industry solution. The issue is not because the researchers think wrongly and the builders think correctly. It's too simple. That's just a simple and non-reasonable idea. Researchers and builders are often operating inside different systems of validation. For researchers, they are trained to begin with research questions. The builder is trained to begin with a user problem. Researchers ask whether the method is novel, it's rigorous, and defensible. For the builder, the solution, they ask if the solution is useful, is usable, and worth adopting. Where the researcher is worrying about how to reproduce the methodology or the given steps, the builder also is concerned about reproducing, but they have an additional question of which can the system scale under real operating conditions? The researcher may treat peer review as a major form of validation. For the builder, they seek market feedback, user behavior, procurement acceptance, retention, willingness of people to pay for it, and the operational reliability. In AI, the difference is especially important because a working model is not the same as a working product. The model may perform very well in controlled environments in the lab. It's plain data sets. And yet, it will fail when it's exposed to poor data quality, ambiguous users, shifting business groups, regulatory concerns, or even integration complexities. So this is why I describe research and product building as different systems of validations. Academic validation asks, is this contribution credible within the knowledge system? The product validation we ask, is this solution valuable within your real-world system? Where both question matters. In fact, the strongest AI product often needs both questions to be answered. You need rigorous research and then the discipline of product development. Where the researcher's mindset asks what is true, what is novel, what is defensible, the builder mindset is focused on what is useful, what is adoptable, and what is sustainable. So the translation problem begins when we assume that answering the first question automatically answers the second one. It does not. Paper may prove that something is possible. A product must prove that something is valuable, usable, and repeatable. So this is the bridge we are trying to build right now. So moving on to the three most common translation problems we have from research to product. There are already many reasons why research fails to become a product, but these three patterns, they appear most often. First one is solving for accuracy and not for usability, which is especially common in AI. Researchers are often trained to improve measurable performance, accuracy, precision, recall, F1 score, benchmark ranking, latency, robustness, generalization of the model. These are the important metrics to researchers. A weak model is rarely a strong foundation for a serious product anyways. But model performance is not the same as the product usefulness. The system can be accurate but difficult to use. It can produce good outputs but requires too much effort from users. It can work technically but fail to fit into existing workflows. It can even be powerful but opaque, making users reluctant to trust it. So from the product context, usability is not a decorative layer added after the model is complete. It's part of the value of the system. Moving to the second failure, which is building for reviewers and not for users. In the academic environment, researchers are rewarded for their novelty, their rigor, their methodological contributions, and their clarity of arguments. They are very valid scholarly standards, very valid. But for users do not usually adopt a system because it is novel. Users don't see the effort that goes into it. They don't care about it anyways. They adopt it because it helps them complete a task, helps them reduce risk, saves them time, it improves their quality of life, It helps them increase revenue or comply with regulations or make better decisions. So this creates a translation problem where a research prototype may be designed to persuade the viewers that the work is original and technically valid. But the product must persuade the users that it is useful, reliable, understandable, and worth changing behavior for. So the third failure, which is keeping validation outside the lab. A controlled experiment can show that an idea works under defined conditions, which is almost very in academic research, we always mostly use controlled conditions for experiments. But deployment introduces new variables, messy data, inconsistent users, legacy system, network constraints, and so much more. Even operational risks. For AI researchers, the lesson is not to abandon technical validation. The lesson is to expand the validation framework. Publishable results asks, does this work under defined condition? Whereas the product reacts additional questions which we must put into place. Does it work for the intended user? Does it fit the workflow? Can it be trusted? Can it be maintained? Can it be integrated? Does it create enough value to justify adoption? So the movement from research to product is not simply a technical transfer. It is a change in the conditions under which the idea must still survive. So a common misunderstanding that research-backed product development means conducting research at the beginning. Then when we are done, we hand the result over to the engineers to build them. So this is not what I mean by research-first product culture. So a research-first product culture treats research as a continuous discipline inside the product lifecycle. The research informs what we need to build, how we will build it, how we validate it, how we deploy it, and how we are going to improve it. At Alveum, this is part of our operating philosophy. Company works at the intersection of AI, which you mentioned earlier, AI and business problems. So we are forced to, not even forced, we rely heavily on research and development. With its leadership having academic roots and the engineering culture encouraging developers to investigate problems deeply before they commit to creating a solution. This matters because many AI projects fails when teams rush too quickly from idea to implementation. In a research-first culture, first question is not simply, can we build this? It is, what problems are we actually solving? And what evidence do we have that this problem matters? The question then continues across the build process. When deciding what to build, the team asks whether the problem is important, recording sufficiently evidenced. When deciding how to build it, the team examines relevant academic work, technical literatures, model limitations, data constraints, and ethical risks. When identifying users, the team studies workflow, incentives, organizational constraints, and adoption barriers. And when validating such system, the team does not rely only on laboratory performance. Looks for evidence of usefulness in context, whether people can use the system, trust the outputs, integrate it into their work, and derive measurable value from it. And when improving the product, the team returns to the evidence again. We are talking about users' feedback, evaluation results, system logs, error patterns, model behaviors, and even newer research that are now out there. So this is also why Alveum organizes research-backed hackathons for their engineers. So these hackathons are not merely innovation theater. They are a structured way to expose the engineers to real industry problems, require deeper investigation, and encourage solution building that is informed by evidence rather than assumption. So this approach is consistent with the broader idea of evidence-based software engineering, which we can describe as a way of integrating current research evidence into practical experience and human values in software development and maintenance decision. For AI specifically, the life cycle view is also important because risks do not end when a model is deployed. The NIST AI risk management framework emphasizes on governance, mapping, measurements, and management as the ongoing functions for AI system that is going to be trustworthy. So when I say Alveum is a lived example of this topic, I'm saying that the company treats research not as a decoration, but as an infrastructure for decision making. The research first culture means the paper, the model, data sets, the prototype are not just isolated artifacts. They become parts of the discipline loop, which is the research, prototype, validate, deploy, learn, and refine. And then the cycle begins again. So I've just prepared this one slide for case study snapshots so that we can have one tangible example. So for this case, I want to use a Nigerian example to illustrate research translation that goes beyond just an idea from a paper to a startup. So in this example, using the N-Atlas, which is the Nigerian Atlas for languages and AI at scale. The underlying problem is both technical and societal. So many global AI systems do not adequately represent African languages, as you all know, if you have been using AI or if you have been an end user, even a researcher in AI. You know, most of these global systems do not adequately represent African language. And within Nigeria specifically, there is a major gap around local languages, accents, dialects, and cultural contexts. So if an AI system is primarily trained on dominant global languages and contexts, it will perform poorly for communities whose speech patterns, idioms, names, and reference, and even linguistic structures are underrepresented in such data. So the research-backed insight is straightforward but powerful, which is local AI capability requires local data, local evaluation, and local linguistic grounding. So this N-Atlas attempts to translate that insight into infrastructure. N-Atlas is an open source multilingual large language model inspired by Awari, and it was launched by the Nigerian Federal Ministry of Communications, Innovation, and Star Economy. The ministry frames it as a way to ensure that Nigeria's linguistic diversity is represented in the global AI. This is important because the product is not simply a chatbot. Significant contribution is the infrastructure layer of the data sets, the language pipelines, speech, and the text system. The developer assets that can support downstream products in education, public service, healthcare, commerce, and governance. I've already also described other related data platforms, such as the Lang Easy, which is used for nationwide local language data collection, and they are rootless for visual data processing. So these are very important because model development depends not only on the algorithm, it's also on the availability, quality, and the representativeness of the data. So this case is especially useful for our discussion because it shows that research translation does not always look like a single product sold to a single customer segment. Sometimes it can come like building foundational infrastructure that other products can build on. So the translation question here is not merely can Nigeria build a language model. It is, can AI infrastructure be built in a way that reflects the linguistic reality of Nigerians and enable practical applications across sectors? So that is the lesson I want us to take from this example. A research problem becomes more powerful when it is tied to a real context. So in this case, the context is language inclusion, digital access, cultural representation, and the need for the AI system that works for local users rather than forcing local users to adopt to some external system. So this is the transition we are discussing throughout this webinar, from research insights to infrastructure, then from the infrastructure to the product ecosystem, then from the product ecosystem to the societal and the industry impacts. So when people hear the phrase turning research into impact, they often really think of turn research into a startup, into a company. Although it's understandable, startup, they are very visible, they are attractive, and often represented as the exciting form of commercialization of research and anything. But it is too narrow. So the first major point in the commercialization playbook that we share is that research can travel through different pathways. The right question is not, should I start a company? It should be, what is the most appropriate vehicle for this research to create impact? So the first pathway I'll be talking about is the spin-off startup, which is what everybody is expecting. So this is appropriate when the research can become the foundation of a standalone product or a platform or a company. A spin-off may make sense when technology is differentiated, the market is large enough, the funding team is committed, and the product requires focused execution that may not fit inside an existing organization. For a startup, it's not always the right vehicle. Some research, they are too infrastructure heavy, they are too specialized, or too dependent on institutional access, or too early for venture creation. That takes us to the second part, which is the industry partnership or licensing. For this model, the research is commercialized through an existing organization that already has customers, has a distribution network, regulatory experience, operational capacity, or even manufacturing capacity. So this is common in technology transfer. The WIPO describe licensing, collaborative research agreements, sponsor research, contract research, and consultancy agreements as mechanism through which universities and research institutions work with the industry. So for AI research, this means licensing a model, data sets, an algorithm, an evaluation framework, or even a patent methodology to a company that can deploy it at scale. It also means co-developing solutions with an industry partner. For the third pathway, which is the consulting and applied research, which is most often underestimated. Some researchers create value not by building the products immediately, but applying deep expertise to complex organization problems. For example, a researcher in machine learning fairness may help a bank audit model bias. A researcher in natural language processing may help a media company build retrieval systems. Or a researcher in computer vision may help an health institution evaluate diagnostic workflows. So this can become a bridge pathway. Consulting can reveal repeated problems across clients, and repeated problems can later become product opportunities. So this now takes me to the fourth pathway of building house at an organization. So this one is especially relevant for professionals in IT or corporate labs, public institutions, NGOs, and applied research and development teams. So not every research-backed product needs to become a external company. Sometimes the highest impact parts is build an internal tool, decision support system, a workflow automation, AI assistant, data platform, or operational capabilities inside an already existing organization. So for this pathway, customer may be the organization itself. The products may not be sold externally, but can still create major value through efficiency, quality, better decision making, cost reduction, or even improved service delivery. This is important for our audience because it lowers the psychological barrier. Commercialization does not always mean fundraising, pitching to investors, resigning from academics, and becoming a full-time founder. Sometimes it means choosing the right vehicle for impact. The startup is one vehicle. License is another. Consulting model is another option. And an internal product is another option. So the academic discipline remains valuable across all four. What changes is the route through which the knowledge reaches the world. So instead, okay. So in startup language, we often hear about the product market fit. It's often been thrown around, and it's usually refers to the point at which a product satisfies a strong market demand. So it's an important concept, but for researchers, it may come too late, their translation journey. Before product market fit, researchers need something peculiar to them, which I can say as the problem research fit. So the problem research fit asks whether there is a meaningful connection between researchers' expertise and a real, painful, unsolved problem in the world. This is important because researchers often begin with what they know. They will say something like, I have developed a model. Oh, I have a data set. I have developed a framework. I have a methodology. But commercialization does not begin only with the assistance of such technical artifacts. It begins where the artifacts can be connected to a problem that someone urgently needs solved. So there are three components to problem research fits. The first is the deep research competence, your research expertise. This is to the researcher's advantage. Researchers often to understand the underlying theory, the methodological trade-offs, the limitation in data, the challenges in the evaluation, and some existing edge cases. They understand it better. They understand it better than. Please, once again, can we mute if we are not talking? Thank you. So, as I was saying, they recognize all these things better than builders or even entrepreneurs. So, the depth matters fairly in AI, where shallow implementation often creates fragile systems. Second component is the painful real-world problem. Problem must matter outside the research environment. It may be painful because it's expensive, it is slow, risky, repetitive, requires too much labor, or even error-prone. So in industry, the pain is often visible through lost revenue, wasted time, regulatory exposure, operational bottlenecks, customer dissatisfaction, and poor decision quality. And the third component of the product problem research fits is the possible translation pathway. The research must be capable of becoming something people can actually use. It could be a model, an API, a workflow tool, a dashboard, a decision support system, can be an automation layer, even a compliance engine, diagnostic assistant, educational system, or even just a consult methodology. But the key question is, where does your expertise make the hard problem newly solvable? So that question is more useful than simply just asking, how do I monetize my research? Monetization will come at the end. That's the last thing that will happen. So the first task is to discover where your research has leverage. For example, as a researcher, you're working on a natural language processing. Might not begin by saying, I want to sell an NLP model. Instead, you will investigate where language tasks are expensive and painful, such as in legal document review, customer support, insurance claims, medical coding, public sector service delivery, even in academic literature. Or a researcher working in computer vision might look for industries where visual inspection is costly or inconsistent, like manufacturing and agriculture or healthcare. And a researcher working in optimization might examine routing, scheduling, supply chains, and the likes. The pattern remains the same. Do not start with the research artifact alone. Start with the intersection between what you know deeply and what the world struggles to solve repeatedly. These are researchers avoid building elegant solutions for problems nobody urgently has. So the problem research fits in the first discipline step towards commercialization because it converts expertise into direction. Tells you which problem deserve investigation, which users to speak with, which industry constraints to study, and which product hypotheses are worth testing. So in much simple terms, I say before asking whether the market wants your product, you ask whether your research is attached to a problem that is painful enough to create demand. So researchers are often trained to complete the argument before presenting it. So a paper is expected to be coherent, defensible, logically sound, complete enough to survive peer review. Whereas product development requires a different thing entirely. In products, really at the early stage of developing a product, the goal is not to build the most complete version of the idea. Goal is to build the smallest version that can produce useful evidence. So this is what I mean by the MVP mindset. So for researchers, the MVP question is, what is the smallest thing you can build to test whether this research solves the problem? This question is different from asking, how do we turn the whole paper into a software? That's what we're asking. It is also different from asking, how do we expose every technical contributions in the product? So the early prototype should focus on the riskiest assumption. For example, if the research uses a machine learning method for detecting financial fraud. So an MVP may not be a complete fraud analytic platform. The first test may be a simple analytic-facing dashboard that compares the model's flagged cases against an existing review workflow. So if the research proposes an AI writing assistant for legal documentation, so the MVP will not be a fully integrated legal tech platform. To be a narrow tool that helps lawyer review one type of clause faster and more accurately. So that's what an MVP will look like. So mostly we're asking the question, we'll not be asking such question like, can we build everything? The question we'll be asking is, what must we build first? What must we learn first? And what is the most tangible thing we can build that can validate our idea? So for researchers, this is a natural extension of the scientific mindset. So MVP is not anti-academic phenomenon. It is an experiment. Unlike a paper experiment, subject of the experiment is not only the model or the method. It's also the user, the workflow, the adoption context, and the value proposition. So that's where the prototype differs from the using paper. Paper proves that the idea is moving. Prototype tests whether the problem is real. Paper proves the methodology is rigorous. For the prototype, test whether the workflow is usable. When the paper test states assumptions, prototype expose whether those assumptions will survive contact with real users and a real environment. So the MVP mindset for researchers is not about lowering standards. It's not about changing the focus of the first build. The first build is mostly and usually not the final product. It's not usually the commercial launch. And it's not the perfect technical demonstration. It is the evidence generating instruments. So if the evidence is strong, you build further. If it is weak, you revise. So if the problem is not real, you stop before wasting years building something nobody needs. So that is what we mean by MVP mindsets, which we need to cultivate. So increasingly, access to powerful models is not a durable advantage. Many teams can use APIs, open source libraries, and foundation models. Advantages even emerges from system being built around AI. We have proprietary context, relevant data, workflow integrations, evaluation loops, human trust, and operational discipline. So research contributing becomes commercially powerful when it is connected to a specific problem. and it is embedded in a workflow where decision happens, and it is continuously measured. And as it's continuously measured, it is also continuously improved in the real world use. So the McKinsey state of AI work always show this that the value is greater when organizations design their workflows around AI rather than just experimenting with AI tools. Even the risk management frameworks reinforce that the life cycle of AI is in trustworthy AI requires governance, measurements, and management beyond launch. So another important thing we need to mention is how to fund this transition, which is almost always the bottleneck we encounter. So funding is often one of the most misunderstood part of research commercialization. Many academics assume that once the research is strong, funding should naturally flow. It's not always the case, or most often it's not even the case. But we know with evidence that funders are looking for different kind of evidence. The research grant is usually designed to support knowledge production, scientific merits, technical feasibility, capacity building, or public value. So in that environment, the language of proposal is often centered on contribution, methodology, novelty, expected outcomes, and societal relevance. But for a venture investor, it is not evaluating the work in the same way. Investor is asking a different type of question. Is this a painful problem? Is there a large market for it? Can this thing build and sell? Will there be early traction? Can this solution scale? Is there a possible route to returns? So this is why researchers must learn to translate not only their technology, but also their funding language. For a grant, the question may be, why is this research important? So for commercialization fund, the question becomes, can this research become a deployable solution? And for an accelerator, the question will be phrased in this way, can this team learn quickly and reach users? And for a seed investor, the question will be, can this become a high growth company? Then for industry partners, it will be, can this solve a business problem better than existing alternatives?
Mr. Habeeb, sorry, Dr.
Yes,
Habeeb, you have more than 3 minutes to go, sir.
How many minutes?
3 minutes, sir.
Oh, okay. All right, let's see if I can. Can you give me 5, please? Instead of 3.
Okay, no problem, sir. No problem.
All right, thank you. So yeah, so I'll quickly just go through it. So as we established, there are different type of questions that different type of people are asking for. We need to frame questions and answers in such way. But we are already used to the way we frame for grants. So you need to transform it to the way we frame it when you're talking to an accelerator program or to the investor. So that's majorly what we need to for transition with funding staff. So for building the team across 2 worlds, on the one side we have the academic world, where it's focused on rigorous evidence-based methodological clarity, reproducibility, theory, and the likes. The other side is the product and industry world that based on usefulness, adoption, speed, workflow, and the likes. Challenge here is how we're going to reach them. So in between, we just need to have the research-backed product that has research depth and has product judgments. And the bridge is the engineering institution. So in this place, the research code and the production system are not the same thing. So we have a prototype that demonstrates feasibility, but the product must still remain reliable, secure, and maintainable. And lastly, the commercialization orientation. So someone must understand what funding, partnership, pricing, and the likes. You need someone that understands that one as well. So in order to create that bridge, there must be the research depth, which is the researcher, someone that understands products, the product judgment, the engineering team that can develop it into a product, someone that knows how to seek for funds. So, honest challenge for this slide. So, researchers, we tend to tell story like researcher makes a discovery, they build a prototype, they raise funds from a company and scale the products. However, it's not usually that way. It's way more complicated than that. So the question, there are so many questions that comes up when you actually get to that stage where you have developed something and it's something that can be commercial. When we start talking about who owns the IP, how do we perform tech transfer, who has the equity, is there a conflict of interest, unit license, not to negotiate with where it was developed. So many more questions that will come up at that stage. So we need to be invested and understand all these technicalities. So in practice, those things will happen. Definitely. That has been developed in the university environment. You need to discuss with your co-researchers at the university about commercialization of something that was developed within their laboratories. So yeah, that is the hardest parts of it. Now moving on to the next slide, I just highlighted some ethical needs that needs to happen at scale. So when you are shipping faster, you have a problem with reduced review and testing. When you have more users using your products, then edge cases starts coming up. Then when automated decisions happens, there is increased in arms that can be caused. You start using more data, there might be privacy and consent risks. You're trying to reduce costs, human oversight may disappear. And personalized experience can introduce bias or manipulation risks. So these are still the challenges that can potentially face when you move from just research to commercial world. And there's also a psychological effect of imposter syndrome, transitioning from an academician or a researcher to a founder. What you are used to previously is different from what you've been needing. So in case of academics, humility actually helps us because to quantify claims carefully, we expect uncertainty, we seek for stronger evidence, research, we acknowledge limitations, and we wait for peer validation. But in the commercial world, and when you become a founder, you delay things like waiting, then you can kill the product. So, and if you continue to have self-doubt, avoiding public commitments, you are refusing to launch until it's perfect, or even underselling yourself, you need to oversell yourself. So those things can happen too, which we famously talk about it in tech as the imposter syndrome. Like you don't belong to where you currently are, you feel like you don't know enough. Whereas you know more than that. So I want us to conduct this readiness check for transitioning from researcher to builder. So for this check, what should we do next? So it offers like a practical but intentional way of qualifying yourself, right? So we have a problem. So you can judge yourself from 0, 1, and 2. For each of the questions we have here, this is unclear 0, partly defined 1, evidence backed is 2. For the problem, what's real, painful, recurring problem does the research addresses? Select 0, 1, or 2. Prototype hypothesis. What is the smallest thing I can build to test whether this creates value? Potential users who experiences the problem strongly enough to attest, adopt, fund, or advocate. then collaborators who can help translate the research into products, engineering domain, or commercial execution. So if your total points is under 3, then you are still exploring. Between 4 and 6, we have a structured discovery. And anything above 6, we have a prototype validation, or we can start pilot conversation. So for if you want to enter the ecosystem from a researcher to a founder, there are some communities or some grants, accelerators that can help with that. So I've identified a few here, which Google for Startup, Accelerator Africa, the NCAI Fund, MEST Africa. Then for research that University Environment, we have the TED Fund and UNDP Innovation and Commercialisation Initiative. We have some open AI communities like Machafin, Deep Learning Indaba X Nigeria. Then you can identify industry partners by submitting proposals and likes. And there are also some founder networks that might be interested in your research and what you're doing. So, can let me complete this sentence. You don't have to mention anything, but I just keep it in mind that my research on whatever research you're working on would help specific people, organizations solve a particular problem. Once you have this complete sentence, then you are on your way to converting your research into commercial products or even a solution. Yes, thank you very much. Thank you for listening. The first takeaway is that the education is not the endpoint. Education validates knowledge, but in AI, if model, assets, a method, it also become beginning of products. Could be a startup, become an infrastructure layer, or even an industry solution. Second takeaway from the presentation is that translation requires a different validation system. So academic validation is different from product validation. The top takeaway is that the next step can be very small. So one research finding, one human problem, one next experiment. So with that, I would like to open the floor for questions and reflections. Thank you very much for listening.
Thank you so much, Dr. Salaudeen. Thank you so much for that insightful lecture. We really enjoyed your lecture, and you've really done justice to the topic beyond publications, turning AI research into startups, product, and industry solutions. You've really dealt with so many issues in line with academic publications, and you've made us to realize that publication in academic only contribute to knowledge improvement and also set a kind of eye-opener to new models, algorithms. But beyond that, AI research about over 1,000 publications has been published, but there's no synergy between the academia and those are in the industry, by which the results, the output of the research can be transformed into economic impact that can solve our society problems. And you've also made us to realize that in AI research, your focus is mainly on research output, and there are translation questions that comes from that research output. And if we're able to provide answers to those translation questions, we'll be able to get an impact vehicle that will transform our society and which will make the research to be impactful to our society. You also made us to realize, you also gave a strong comparison between what a researcher does in academic environments and what a builder that works in the industries looked at. Researchers focused on the novelty of their research, while the builders are interested in how impactful or what is going to be the usefulness of this research, or what is the problem, the societal problem this research work tends to solve. And you eventually tells us that the AI research should be impactful, should be tailored towards impacting the society solving our societal problems, and there should be a kind of synergy between the academia and the industrialists. So I'll be able to solve problems that are related to our societal problems. So on this note, I would like to appreciate you once again for that insightful lectures. Thank you so much, Dr. Salaudeen Habeeb. So on this note, we'll give room for questions and answer. Sorry, questions. Please, would like to take 2 or 3 questions from audience. Thank you. Okay. Dr. Abdulkareem. We have Dr. Abdulkareem. Can you please ask your questions? Thank you, sir.
Well, it's me, the chairman, and I'm not a doctor. I think the government has banned honorary doctor, so I can't even be honorary doctor. And as I used to say, one cannot vex and say, "Let me just go and do a PhD." I will have just vexed to go and do one immediately. So thank you so much. Thank you so much, Dr. Habeeb Salaudeen. And also, I know the PR will do vote of thanks, but I also want to personally thank the Zonal Coordinator. He's always been there for us, and he's here again today for always being part of our webinar. We really appreciate the time you give to us. And before I proceed, also, I want to also reiterate what he mentioned. Please take note that our national conference has been shifted, has been brought forward, and is now going to hold in July and not in August as was announced earlier. I'm trying to check there. I don't know the date offhand, but it's going to hold in July. We've shared that on the platform on the NCS platform earlier, and it's also on our Facebook page. So for those planning to come, I believe everybody will be planning to come. It's going to hold from July 27th to July 30th in the city of Jos. And I mean, the local organizing committee, the conference committee is doing all its best to ensure we have a very successful conference. We'll be talking more about that when we have our next general meeting. Now, my own question or contribution is that when we look at the advanced economies or advanced countries, we know that the industry invests heavily in research and development. And most of the funds, or some of the funds spent on research and development, are actually spent in tertiary institutions, so that there's a partnership between the academia and the industry, where the academia does research to provide solutions to problems that the industry or those in the industry have. But I don't know, those who are in academia who are here, if what can we do, or what are we actually doing to ensure that we have such deepened collaboration, so that our research or the research of our researchers will not just end up before it used to just end up in the library, so it doesn't end up just in the cloud without them being implemented. Thank you.
Thank you, sir. I think I want us to take all the questions together. So while Dr. Habeeb answers all the questions one after the other, not to save my time. So next person, Mr. Idris Abdulkareem. You have the floor, sir.
Yeah, thank you so much for the opportunity. Good evening once again. I'm by name. I'm Idris Abdulkareem. I am a MSc student in University of Maiduguri. Though I am a mathematics student, I do my BSc in mathematics, and I roll into MSc optimization, mathematical optimization. So my question, and as well, I can say I'm looking for advice, because I want to do my research on optimizations. So looking at the revenue that we are generating in oil sector, so I want to use this mathematical optimization to optimize the revenue we are generating in oil sector. So please, like I've said earlier, my research in undergraduate, the research coordinator didn't give me the opportunity to learn very much. So now I am into MSc. I don't have much knowledge about research. So please, I don't know if I can be able to have some advice, despite the fact that I gain more from this just concluded presentation by Doctor. So please, that's my question as well, looking for advice. Thank you.
Okay. Thank you, sir. So next is Mr. Adeshegun Adekunle.
Okay, thank you, the moderator. Segun Adekunle is my name, the Executive Secretary of Nigerian Computer Society. I want to appreciate the President who has just given us the opening remark. Also, the Zonal Coordinator, Dr. Oyerinde. The chairman also, we appreciate you for the work, the good work you are doing. This is a laudable achievement. At least was able to listen from the beginning to the end. And I see a very impactful knowledge in this lecture. I want to also appreciate Dr. Habeeb for really taking his time to give us this very insightful topic. I think my submission, hello? Yeah.
Hello, we are with you, sir.
I want to buttress on what Chairman said for benefit of our NCS members there listening to us. We are having a cybersecurity conference, cyber security forum in June 17th to 18th of this year at Abuja. If you want to participate, it's going to be impactful. Chairman has told us about the July 27 to 30 for our main conference, which is coming up in Jos. We've gone there to see, and we have testified that that place is well secure. So all our members can come in and have a very nice outing at Jos. So my own appeal is to the chairman and the organizers. If recording of this program can be shared to the members, it will be good. Thank you very much for the good work you are doing. Thank you.
Thank you, sir, the Executive Secretary. The moderator, are you there?
Yeah. Maybe the presenter can go ahead and answer the question. I think the moderator maybe having a network.
Okay, thank you, sir. Thank you. All right, so I have two questions. One asked by engineer. So this is about the advanced countries having access to funding from different
Dr.
industries.
Habeeb, sir.
Yes, ma'am.
Please, before you take all the questions, let me include add this one that was posted on the chat.
Okay.
What are the practical AI policies that can be created for schools, offices, government agencies, businesses, and organizations to guide the proper use of artificial intelligence? Thank you. Thank you, sir. You have the floor.
All right. So answering the first question that what can we do to improve that? Honestly, when I was coming up with the presentation, I had that thought as well. And I wanted to add it, but just given the Nigerian landscape, we realized that we could just talk about it, but it doesn't seem like anything will change. So there is no enough government backings, and the socially big industries are not particularly investing in research. There is no funding, no grants, and the likes. But what I can say is we can look out to international organizations. I think there are a number of them that you can apply to globally. They accept from anywhere as long as your research standard and you are solving a unique challenge. The one I've explored in the past is open philanthropy, something like that. And I think there is still a number of them. But within Nigeria, I really do not know, to be honest. We can just hope and pray that it gets better. But instead of waiting around, you can actually just shoot your shots at international organizations that are willing to fund research across the globe. There are even some that are specific to regions. So you'll be hearing Africa or West Africa, some particular type of research. You just need to keep an eye out for that. And you can apply as an institution, as an individual, as a researcher, even as a technologist. So I guess that will answer that question partly. But what can we do as for the Nigerian context, I really don't know. But yes, let's just look outside Nigeria if possible. So for the second question, which was asked by a gentleman from the University of Maiduguri about focusing on optimization of oil sector revenue, which is his focus in energy. And he mentioned that it does not have in-depth research knowledge. Well, I think that's where you should start from, is trying to become a researcher. I understand you're just starting MSc, and that's what MSc actually teach you. So you should be patient, but just don't lie around and wait for when you continuously learn. So you can actually focus on literature reviews, right? Find relevant papers that are recent, that are in the space of optimization, or specifically in the oil sector. So for the optimization, I'm assuming doing something related to AI. So you can focus on that and just keep reading papers and try to understand the problem statements, the methodology, and the results. So keep doing that. Eventually, you will start cultivating your own questions and hypotheses too. And that's the beginning of every research, because if there's no research, there is no question. So once you start asking questions, you start looking at potential solutions. So another way is you can also follow some global industries that they have already improved or optimized that areas in oil sector. You just follow what they do. Some of them release white papers, or even just a blog post. And even some of them actually have research papers out there that you can read and understand what they have done in that field. So usually just keep learning, and we start understanding and start questioning things as well, which will serve as the foundation of your research mindset. I don't know if that answers your question. And for the third question, so what are the practical AI policies that can be created for schools, offices, government agencies, businesses and organizations to guide the use of AI. So application of AI is still relatively new, although it is being used at a very, very fast pace. So we are still doing catch-ups. And that's why it feels like ethical AI and civil AI are very important at this point. Because superior to AI, just like we had social media back then, it's until later on that we start seeing the negative effects. So this also will come with positive and negative effects. But practical AI policies that can be introduced, that can be applied across different organization agencies would be creating maybe like an AI acceptance use policy that will define what tools should be used by schools, by companies, what type of data should be shared. I mean, at least for some of the I've worked with, or even at Alveum, they have some policies guiding how developers use AI. Like you can't build proprietary code in the chatbot, and you can't share users' data, things like that. So something like that should or will be created, and gives a guideline on exactly how it should be used, how teachers, how students should use it, and the likes. It also covers partly data privacy and policy. I've mentioned has to be compliant to whatever data regulatory listing that we have countries. And whatever tool that will be used to should be ethically certified. It must have gone through maybe some body must have also already evaluated the tool in and out, everything, and ensure that this is safe to be used and doesn't expose it to unnecessary risk. So I think that's what comes to mind on the spot.
Okay.
But yeah, we can just like I think that's it. That's it. Thank you very much.
Thank you so much, Dr. Habeeb Salaudeen, for that response to all our questions. This, I think we can make it. We'll make his email address or phone number available in case if you have any questions. And before we end up the session, I'd like to inform all the participants that the slides for the presentation and the recording will be sent via our email. So participants should be expecting the slide. So on this note, I'd like to invite, thank you so much for your responses. I'd like to invite my immediate past treasurer of NCS, Kwara State Chapter, and my immediate past former head of department, Computer Science, Kwara State University, and my senior colleagues, Dr. Ronke Sheyi Babatunde, to please give us a closing remark. Thank you, ma'am.
Good afternoon, everyone. Good afternoon, sir. Good afternoon, ma. I believe you can hear me, sir, and ma.
We can hear you, ma'am.
Okay, thank you. Thank you for this opportunity. I want to appreciate everyone that is able to join this very insightful and impactful webinar this evening. I want to believe that these 2 hours or less than 2 hours that we have spent sitting down and listening has never been a waste at all. On my own part, I've learned so much, a lot of insights and light have been shed into our research area. When it comes to artificial intelligence, a lot has been covered. We have been taught by our dear guest speaker a lot, and I believe we are going with a lot of actionable insights. And I believe at the moment we are going to start acting. He has said so much, and a lot of take home that we have this evening. He has made us to understand in summary that we are expected to create a path for our AI solution, and we should have the end user at the back of our mind if at all our solution and publications are going to turn into products. He has said so much, and I want to really appreciate you. Thank you so much for sharing your knowledge. Thank you for giving us this insight. And I also want to appreciate the leadership of NCS Kwara Chapter. I appreciate you so much, our dear chairperson, our chairman. Thank you so much, Engineer Taofik. I want to also appreciate my current head of department in person of Dr. Mrs. Ajao. Thank you so much for this putting up this program together. The executive as a whole, I couldn't mention all the executives, but then I want to appreciate every executive members that have deemed it fit to put up this kind of webinar together at this evening. Thank you for considering bringing this particular speaker in person of Dr. Habeeb Salaudeen. Thank you for your, sharing your resourceful knowledge with us. I want to assure us that, the treasurer has said, the slides and the recording will be available. So let's follow up to get the information, and let's start taking action right away. Thank you very much, and have a pleasant evening, everyone. Thank you.
Thank you so much. That's a wonderful one from my senior colleagues, Dr. Ronke Babatunde, the immediate past treasurer, NCS Kwara State Chapter, and the immediate past head of department, Computer Science, Kwara State University. Thank you so much, ma'am. So on this note, I would like to invite our PRO of NCS Kwara State Chapter in person of Mr. Taofik Abiodun Ahmed to please give us vote of thanks. Thank you, sir.
Thank you very much, ma'am. The moderator, thank you so much. On behalf of NCS Kwara, I would like to appreciate the presence of every individual that have joined today webinar. We really appreciate you. Also, I would like to especially appreciate the NCS president, Professor Sirajo, the Zonal Coordinator, North Central, Dr. Oyerinde, and also the Executive Secretary, Mr. Adeshagun Adekunle, for joining us today. I believe today is another beautiful day. Organizing this webinar, which is so insightful. I believe everyone have learned one or two things. We really understand, or we really understood how the relationship between academia and the industry need to be strengthened so that we can take Nigeria to the greatest height. I would like to appreciate the chairman of Kwara State Chapter, Engineer Taofik Abdulkareem, for always being there, for always being proactive, and also the entire executive, starting from the vice chairman down to the PRO2. I really want to appreciate you for always being in support of the chairman of NCS Kwara in order to achieve all these feats, in order to take Kwara State NCS to the greatest level. And to every participant that joined this webinar today, we sincerely want to appreciate you, and we pray may Almighty God continue to bless each and every one of you. Thank you once again. And to the moderator, who has coordinated excellently, my Oga, Associate Professor Mrs. Alilat Ajao. Thank you so much for having me in your midst today. Thank you.
Yes, thank you so much, our powerful PRO. We appreciate you. Yes, on behalf of the chairman, NCS Kwara State Chapter, person of Engineer Taofik Abdulkareem, and other executive members and all professional members, we want to bring this webinar to an end. So thank you. We appreciate each and every one of you, and I wish you God bless, and I pray to God Almighty Allah to preserve each and every one of us to see beyond today, so I'll be able to witness more of this. So thank you so much. So I appreciate every one of us. Thank you, sir, and thank you, ma'am.
Thank you, ma. Thank you very much, ma. Thank
Thank
you,
you
sir.
so much.
Thank
Have a
you,
nice day, everyone.
Yes.
thank you, Yaro, sir. Thank you, ma.
We appreciate you.